Today in this video lecture, we will see numerical 4 on design of shaft. Numerical, a hollow cylindrical shaft 1.5 meter long. It has an inner and outer diameter respectively equal to 40 mm and 60 mm. What is the largest torque that can be applied to the shaft if the shearing stress is not to exceed 120 MPa? And what is the corresponding minimum value of shearing stress in that shaft? So given data in this numerical is length of shaft capital L is equal to 1.5 meter, inner diameter small d is equal to 40 mm, and outer diameter capital D is equal to 60 mm. And shearing stress is not to exceed, shearing stress tau not exceed, that means not greater than 120 MPa. And to find torque T and minimum shearing stress. Largest torque, that means maximum torque. So see, this is hollow cylindrical shaft. Material, which material they use for making this shaft, they don't tell us in this numerical. They only tell us length of this shaft is 1.5 meter, diameter small diameter, internal diameter is 40 mm and external diameter is 60 mm, and shearing stress is not exceed 120 MPa for calculation of this maximum torque. And by using this maximum, so no, and secondly we have to find minimum shearing stress. So we will see this numerical step by step. First step for solving this numerical is to find polar moment of inertia. And why we find polar moment of inertia? Because this polar moment of inertia, this polar moment of inertia is required while calculation of torsion. While calculation of torsion in torsion formula, T by J is equal to tau by R formula. So polar moment of inertia and for hollow shaft it is pi by 32 into d raised to 4 minus small d raised to 4. Pi by 32 multiply by external diameter raised to 4 minus internal diameter raised to 4. External diameter is 60 and internal diameter is 40. So 60 raised to 4 minus 40 raised to 4. Pi by 32. So this polar moment of inertia value is 1.021 into 10 raised to 6 mm raised to 4. 1.021 into 10 raised to 6 mm raised to 4. Now next step is calculation of this torque. First, maximum torque. So for this, maximum shear stress occurs at radius C. This is small radius, smaller, and this is capital radius capital R. So this maximum shear stress occurs at this capital R radius. So maximum shear stress occurs at sorry for noise disturbance. Maximum shear stress occurs at capital R is equal to small capital D by 2, and this capital D is 60 divided by 2, that means it is 30 mm. So this capital R is 30 mm. So use this formula T by J is equal to tau by R for calculation of this T. So this T as it is J we had calculated it in step 1 1.021 into 10 raised to 6, and tau is maximum tau 120 MPa. Use maximum because of we require this T maximum. So tau is 120 and radius is this 30. So this T is equal to 1.021 into 10 raised to 6 into 120 divided by 30 is 4.084 into 10 raised to 6. And unit is C. This is in mm raised to 4. This is in Newton per mm square, and this is in mm. J is in mm raised to 4. Tau is in MPa, that means Newton per mm square, and mm. So unit is Newton mm. Now next, this tau minimum shear stress occurs at inner face. So for calculation of this tau minimum, minimum shear stress occurs at small r is equal to small r is this diameter is 40, that means 40 divided by 2 is smaller. Smaller is 20 mm. So same formula we will use for calculation of this tau minimum. T by J is equal to tau by R. And here R is small r because this minimum shear stress occurs at small radius. T is this is T. 4.084 into 10 raised to 6. This J is this 1.021 into 10 raised to 6. This is tau minimum, and R is this 20. So tau minimum is see numerical once again. While corresponding the minimum value of shearing stress in the shaft, what is the largest torque that can be applied to the shaft if the shearing stress is not exceed 120 MPa? And while is what is the corresponding minimum value of shearing stress? Corresponding, that means for this T value, for this torque, for this calculated torque, what is the corresponding minimum shearing stress? That's why I put here this T is calculated T. So 4.084 into 10 raised to 6 into 20 divided by 1.021 into 10 raised to 6 is 80. And unit is this T is in Newton mm. This is in mm raised to 4 and this is in mm. So and this tau minimum mm raised to 4. So Newton per mm square unit or MPa. So they provide us length of that shaft, small diameter of that shaft, and external diameter of that shaft, and shearing stress not exceed 120 MPa. And by using this data, we had find this maximum torque and minimum shearing stress. And in this numerical, we had used polar moment of inertia formula for the hollow shaft. We know maximum shear stress occurs at maximum radius, and we had used torsion formula T by J is equal to tau by R. Why we don't use G theta by L in this equation? Because we don't know angle of twist, we don't know shear modulus. That's why we don't use this G theta by L in this numerical. And minimum shear stress occurred at small radius. And by using same torsion formula, we had find minimum shearing stress 80 Newton per mm square minimum shearing stress, and maximum torsion is 4.084 into 10 raised to 6 Newton mm. This is maximum twist. Maximum torque, you may call this torque, torsion, or twist. Torsion unit is Newton mm and shearing stress unit is Newton per mm square. Shearing stress 80 Newton per mm square and torque 4.084 into 10 raised to 6 Newton mm. Yeah. Thank you very much.